Here we're going to solve a system of equations using matrices. We need to solve this system: x plus 2y plus 4z equals negative 3, 2x plus 7y plus 15z equals negative 12, and 4x plus 7y plus 13z equals negative 10. First thing we'd like to do is to write down our augmented matrix. Remember that the augmented matrix consists of two parts. We have all the coefficients for the variables. This first column would be the coefficients for x, then coefficients for y, then we have coefficients for z. Then this is the right-hand side, or our constant coefficient. When we solve systems using matrices, the first thing we'd like to do is get a 1 in the upper left corner. We want 1s along this main diagonal. This is already a 1, so we don't need to do anything for that. After we get a 1 up here, we'd like to get zeros beneath that. To do that, we need to change our second and third rows to get zeros below. Our new row 2 will equal negative 2 times row 1 plus row 2. And we can change row 3 at the same time. Our new row 3 will equal negative 4 times row 1 plus row 3. If we perform those operations, we'll get the following matrix. We haven't changed our first row, so we just rewrite that. Then we need to perform this operation to change our second row. We get negative 2 times 1 plus 2 is 0. Negative 2 times 2 plus 7 is 3. Negative 2 times 4 plus 15 will give us 7. Negative 2 times negative 3 plus negative 12 will give us negative 6. To get our new row 3, we perform this operation. We get negative 4 times 1 plus 4 is 0. Negative 4 times 2 plus 7 is negative 1. Negative 4 times 4 plus 13 is negative 3. Negative 4 times negative 3 plus negative 10 is 2. We're going to continue on another piece of paper. Here we've rewritten our last matrix. Remember, our goal is to now get a 1 in the row 2, column 2 position. We could do that by multiplying this second row by 1/3, but that will lead to some fractions. An easier way will be to switch the second and third rows and then multiply the second row by a negative. We can accomplish that by saying that our new row 2 is equal to negative row 3, and our new row 3 is equal to the old row 2. If we perform those operations, we'll get the following matrix. We did not change row 1, so that stays the same. Our new row 2 is the opposite of the old row 3, so 0 times negative 1 is still 0. Negative 1 times negative 1 is positive 1. Negative 3 times negative 1 is positive 3. And 2 times negative 1 is negative 2. We're saying that our new row 3 is the old row 2, so we just rewrite this row down here for row 3. So now we have 1s on the first two entries on our diagonal. We'd like to get a 0 underneath this one. To do that, we're going to change row 3, and that's going to equal negative 3 times row 2 plus row 3. If we perform that operation, we get the following matrix. We did not change the first two rows, so we rewrite those. To get our new row 3, we take negative 3 times 0 plus 0 is 0. Negative 3 times 1 plus 3 is 0. Negative 3 times 3 plus 7 is negative 2. Negative 3 times negative 2 plus negative 6 is 0. The last thing we'd like to do here is to get a 1 in this 3, entry. To do that, we're going to multiply row 3 by negative 1/2. If we perform that operation, we get the following. We did not change the first two rows, so we rewrite them. If we multiply the third row by negative 1/2, 0 times negative 1/2 is 0. 0 times negative 1/2 is 0. Negative 2 times negative 1/2 gives us positive 1. And then 0 times negative 1/2 is again 0. Now we have our matrix in row echelon form. We can go ahead and solve the system using back substitution. This last row tells us that z is equal to 0. So we know the value for z. The second row gives us the equation y plus 3z equals negative 2. Since we know what the value of z is, we can plug that in, get y plus 3 times 0 equals negative 2. So y is equal to negative 2. We know z and y now. This first row in our matrix gives us the equation x plus 2y plus 4z equals negative 3. Plug in our values for y and z. Get x plus 2 times negative 2 plus 4 times 0 equals negative 3. So give us x minus 4 equals negative 3, or x is equal to 1. Now the values for x, y, and z gives us our ordered triple solution, 1, negative 2, 0. Remember, you should go back to the original system of equations and verify that this is indeed the solution and it satisfies all three of the equations.